what exactly should a modern data center architecture look like? If we were just deploying a data center infrastructure solution from scratch for let's just say it's a medium to large organization. We've probably got at least a dozen, if not a couple of dozen racks with servers in it. What would this look like? How would you design this? Well, the way that I would look at it and the way that a lot of modern data center architects would look at it is that we want to embrace a couple of technologies, and the first of which is the spine leaf architecture. The spine leaf architecture is essentially a way for us to ensure that we can fully scale out a data center environment from a layer 2 perspective, ensuring that we have layer 2 everywhere in the data center. It's usually a requirement of data center architectures. And yet we have layer 3 between the nodes, meaning that when we connect all of this up, we'll see that we don't actually have any layer 2 links in here. The magic to this is to allow us to deploy VXLAN, which carries layer 2 over layer 3. And the most important aspect of this architecture is, simply put, we can eliminate spanning tree. We don't have to block any links, and we don't even have to leverage complex technologies like virtual port channel. This is optional. We could deploy virtual port channels, or we could say no to virtual port channels, but ultimately we are cleaning up our layer 2 environment and taking advantage of layer 3. This is one of those rare cases, I would say in networking, but really in life, where we can look at this and say, you know what, I want the best of both worlds. If I came to you and said, hey, do you want the flexibility of layer 2 everywhere, or do you want the scalability of layer 3 everywhere? And you looked at me and you kind of thought about it and you said, I want both. Well, 20 years ago, I would have looked at you and said, no, seriously, you have to pick one. Because our architectures didn't support the ability to do that. We didn't have a protocol like VXLAN. Well, VXLAN was a game changer. VXLAN allows us to truly say, okay, you want both? Let's deploy both. And again, it's rare in life we can say this, but I can truly get the best of both worlds by deploying a layer 3 solution that allows me to scale out to as many of these switches as I want, because it's just a layer 3 converged infrastructure. And yet I continue to put layer 2 everywhere inside of the data center. And so that's great. I could just go around and configure spine and leaf architectures. But there's another trend in the modern data center that is very important, and that is a couple of concepts that we could call software-defined networking. What I mean by this is we're really talking about a couple of aspects. First of all, we care about programmability. If I think about the largest data centers that I can imagine, which maybe would be a public cloud provider, maybe a large enterprise architecture, something along those lines. I used the example earlier. Imagine I want to add a VLAN into this environment. Or if I'm a service provider, maybe I want to add a customer. Well, the old way of doing this was to send a network admin out, maybe with their laptop, and they'd plug into a switch and we would make that configuration. Now, even a long time ago, we probably wouldn't physically go there. We might use an SSH session for this, but ultimately I'm entering commands via the CLI, the command line interface. So this is our standard iOS and NXOS commands that sound familiar to us. It's config T and it's interface Ethernet 1/1 and it's switch port mode trunk and all of these commands that, hey, I love. I mean, I have a CCIE and data center, and so I absolutely love entering these commands on a Nexus switch. I've spent hours and hours of my life learning those commands. And yet, when I think about the scalability of this, if I'm thinking about scaling up to dozens, if not hundreds of racks and rack switches, now all of a sudden this architecture we see doesn't exactly fit the bill. It's not giving us what we're looking for. And so programmability allows us to make these changes in a way that can be dynamically pushed out, not only from a scaling perspective, but even from a dynamic perspective. Meaning that, yeah, we can make many changes at once, but we can make changes on an as-needed basis. I can push configuration changes out, like adding a new customer, and then maybe that customer was just a temporary fixture. Maybe they just needed to be in here for a month or two. And so then we pull that configuration back out of our data center. Or think about access control lists and how hard it is to actually remove lines in an access control list because everybody's afraid of breaking something. We say, well, if a configuration's in place, we might as well leave it forever. Well, we can be a little bit more dynamic than that, especially in environments that are a little bit more dynamic. And so programmability is important, but it's not just a matter of, well, now me as the admin, I'm going to use something like a REST API call. That's huge. I mean, it's really fun for me to make my own REST API calls. But in order to really embrace this model of saying we need to scale out and have dynamic pushing and pulling mechanisms, we also need to have a controller-based architecture. Some kind of SDN controller that now is going to sit out here, and this controller is going to manage the environment for me. So now we're not talking about just you switching my method. We're actually in some ways removing ourselves from the equation, or at least changing where we make our changes. So now I am an admin and I'm actually logging into the controller, and this controller will make those push and pulls, and for that matter can be configured to automatically do a lot of those things. In fact, this leads us to another very important point, which is the concept of well, it's a concept that we call, or sometimes refer to as intent-based networking or policy-based networking. But here's the idea. What if I just wanted to say, you know what, I want VLANs 20 and 50 to not be able to talk to each other? How would we do that in today's data center space? If we didn't have VXLAN and we didn't have SDN controllers, how would I go about doing this in a traditional CLI environment? Well, I'd probably use some amount of access control lists. I might have to use VLAN access control lists at layer 2. There's a lot of configuration that I'm going to have to do in order to make this happen. And this gets more complex if I say, well, now I want VLAN 30 to be able to communicate to VLAN 20, but also not be able to communicate to VLAN 50. So maybe we'd start to talk about private VLANs at that point, but again, these mechanisms never really scaled, and a lot of engineers, myself included, were never super comfortable deploying VACLs and private VLANs. These were mechanisms that in some ways worked when we needed them to, but it caused problems, very cumbersome configurations that were difficult to support when there were problems on the network. So this intent or policy-based networking concept basically says that I'm not even pushing direct configuration changes to the controller. Instead, I'm pushing policy. I can go to this controller and I can say, I want essentially this configuration, and I don't care how you do it. Now, this is hard for a lot of traditional network engineers, again, myself included, to say, what do we mean we don't care how we do it? I mean, how are we doing it? Are we deploying it with access control lists? Are we going to use private VLANs? I mean, what are we going to do to enable this functionality? And the point is, it doesn't matter. And it's better if we don't have to worry about it, because what I'm actually saying is I just want the job done. How you do it is up to you. I just want to make sure that these two VLANs can never talk to each other. And so that is ultimately what we're talking about here, is we're relinquishing a little bit of control, kind of, because what we're really relinquishing control of is the mechanisms, the technical aspect of it. But what we're not relinquishing control of is the policy. And so now I can look at a data center and say, I want this policy deployed, and my controller will be able to do that. And this isn't just a Cisco concept. I mean, all of our software-defined networking controllers on the market are able to do this kind of concept. And yet, again, this isn't a matter of this is something only ACI can do. It's just that Cisco has given us a prepackaged solution that brings a lot of these technologies together. And so it allows us as the network admins to focus on the policy and less on the minutia, or in other words, less on the details of how to make something like this happen. So lastly, when we tie all this together and we say Cisco ACI is going to bring this together for us. It's going to allow us to build this out. It's going to build the spine and leaf architecture, as we've said. It's going to deploy VXLAN for us. It's going to allow us to scale up. And the way it scales is by leveraging spine and leaf and VXLAN, but also programmability. So our APIs, which again allow us to be more scalable and more dynamic. And ultimately, it also includes that controller element, which allows us to focus more on policy rather than on mechanisms and protocols and the like. In fact, Cisco ACI configures this layer 3 routing domain for us in here. And I don't get to choose which routing protocol. Cisco ACI is going to choose the routing protocol because I should not have to care about how all of these switches reach one another from a layer 3 perspective. And so that's the kind of concept where we use this word abstracting. We're saying when we abstract something, essentially that now we don't care. The things that we care about have changed. I'm no longer worried about the config, but rather I'm concerned about making sure that the data center is working how I want, which is, again, what we call the policy. Now, one fascinating part about this conversation that some people don't really like to talk about is the concept of vendor lock-in. And I mention this now, even though it's a little bit of a dated conversation, but it can still come up. When Cisco ACI first came out, a lot of the SDN proponents in the industry loved how SDN could be open source and it could be ultimately a multi-vendor deployment, because I could deploy some controller from vendor A and I could deploy switches from vendors B, C, maybe even some A, some that made the controller and the switches. But because everything is open source and we have protocols that have been developed for the industry to use, that we could just deploy whatever we want. And when Cisco ACI came out, Cisco says, hey, we need to deploy this on Cisco hardware. So the controller, the switches, they all have to be Cisco. And so, again, some SDN proponents who loved the multi-vendor aspect said, oh, this is no better than anything else that Cisco ever does because it's vendor lock-in. If you wanted to deploy a new switch and you deploy on an ACI, you have to go out and buy a Cisco switch. Well, the reason I say it's a little bit of a dated conversation at this point is because, yeah, it can still come up, but generally speaking, that vision of SDN never really came together. For the most part, especially larger scale data centers, especially data centers that aren't just built by one person, which, at that point, who knows what's getting deployed. But when we're talking about data centers like that, they usually would lock in with a single vendor anyways. Because who really wants to have a data center built on multiple vendors, even though it might get better pricing that way in some situations? That's even debatable. Now I have to call 2 vendors or 3 vendors or 4 vendors when there's a problem in my data center. Because maybe the problem's with the controller, or maybe the problem's with vendor A's switch, or vendor B's switch, or vendor C's switch. And most organizations have moved away from that. And so is there vendor lock-in? Yes. We absolutely have to use Cisco hardware. But a multi-vendor data center, once again, is sort of just our reality. We're always going to have, or I should, it's a reality that we're not going to use multi-vendor. There we go. We're pretty much locking into a single vendor, even if we're not going with a Cisco solution. Even if we're not going with Cisco ACI, and we said, okay, I don't want to use ACI, but I want to build out my architecture like this. As we said, you can do that, and you can do it on Nexus 9Ks, but you're probably not going to do it on Cisco Nexus 9Ks and then some kind of non-Cisco set of switches as well. We usually are going to pick one or the other. So the multi-vendor conversation isn't as big of a deal. And instead, what we're going to find is that we do have to build this on Cisco hardware, specifically Nexus 9Ks, and the controller, which is known as the Application Policy Infrastructure Controller, or as we said earlier, the APIC. So this is how ACI is built out. We are looking at these specific benefits and these specific technologies, and it's all brought together on hardware that Cisco makes that we can purchase and bring together once again as this prepackaged solution.
Thanks for watching. Be sure to click here to subscribe to CBT Nuggets and click the notification bell to make sure that you're aware of every time we post new content. If you're interested in a career in IT or you want to brush up on your IT skills, then swing over to our website, and while you're there, be sure to sign up for a free trial.